steric repulsions. Repulsion between non-bonded atoms. Repulsion between non-bonded atoms or groups is known as steric repulsions. Repulsion between non-bonded atoms or groups is known as steric repulsion. We can understand this one from the cis-2-butene and the trans-2-butene. Cis-2-butene and the trans-2-butene. In the cis-2-butene, both methyl groups are present on the same side. When groups approach closely together, forces of repulsions come into play. These forces of repulsions are known as steric repulsions. That means cis-2-butene suffers from the steric repulsions because the size of the methyl group is higher than the H atom. While in the trans-2-butene, H atom is smaller. As a result, between the H atom to methyl group, steric repulsions are not operated. So, trans-2-butene is more stable than cis-2-butene. Because of the steric repulsions, cis-2-butene is less stable than trans-2-butene. Now the steric inhibition of resonance. Steric inhibition of resonance. An essential requirement for resonance is that all the atoms covered by delocalized electrons must lie in a plane or nearly so. An essential requirement for resonance is that all the atoms covered by delocalized electrons must lie in a plane or nearly so. If planarity is absent, if planarity is partially reduced, or completely prevented by the steric effect of a group, resonance is diminished or prevented. If planarity is partially reduced or completely prevented by the steric effect of a group, resonance is diminished or prevented. In these circumstances, the phenomena is known as steric inhibition of resonance. We can understand this one from the picryl iodide. This is the picryl iodide. This is the picralide. The oxygens of the para-NO2 group lies in the plane of the benzene ring. The oxygens of the para-NO2 group lies in the plane of the benzene ring. As a result, between the benzene ring to para-nitro group, resonance is operated. Resonance is operated. Resonance is operated. That means corresponding resonating structure is like this. If you observe these two structures, the CN of the para bond has partial double bond character. The CN, C bond N, CN of the para-NO2 group has partial double bond character. Partial double bond character due to resonance between the benzene ring to para-NO2 group. While in ortho-NO2 case, the oxygens of the ortho-NO2 group sterically forced out of the plane of the benzene ring. The oxygens of the ortho-NO2 group sterically forced out of the plane of the benzene ring by large iodine atom. Large iodine atom. As a result, between the benzene ring to ortho-NO2 group, resonance is diminished. An essential requirement for resonance is that all the atoms that are covered by delocalized electrons must lie in a plane or nearly so. Here para-NO2 to benzene ring, no steric repulsions are operated. As a result, para-NO2 is coplanar with the benzene ring. Means a benzene ring to NO2 resonance is operated. As a result, the Cl has some partial double bond character in para-NO2 case. Why in ortho-NO2? Due to steric effect, NO2 is not coplanar with the benzene ring. That means the CN bond of the ortho-NO2 does not get partial double bond character. If planarity is absent or planarity is partially reduced or completely prevented by the steric effect of a group, resonance is diminished or prevented. Here the resonance is diminished because of the steric effects of the oxygen and the iodine atom. Oxygen of the ortho-NO2 and the iodine atom. As a result, this CN bond length, the ortho-CN bond length is longer than the para-CN bond length. Therefore, bond lengths, if you will compare bond lengths, if I denoted the ortho-CN bond length with the A and the para-CN bond length with the B, ortho-CN bond length with the A and the para-CN bond length with the B, A is larger than B. benzoic acid. Benzoic acid is planar. Benzoic acid is planar. Benzoic acid is planar. And so, carboxyl group is coplanar with the benzene ring. That means both carboxyl group and benzene ring lies in the same plane. Same plane. As a result, benzene ring can access the plus R group. Benzene ring can access the plus R group. Plus R group. Plus R group. That means benzene ring to carbonyl group of the carboxyl COH, carbonyl group of the COH, resonance is operated. The pi-pi conjugation. The pi-pi conjugation is operated between the benzene ring to carbonyl group of the COH. This pi-pi conjugation prevents the extent of the lone pair pi bond conjugation. This pi-pi conjugation prevents the extent of this lone pair pi bond conjugation in benzoic acid. An ortho substituent prevents this coplanarity. An ortho substituent prevents this coplanarity. An ortho substituent prevents this coplanarity due to steric effects of the methyl group or the carboxyl group. Means carboxylic acid group carboxyl group does not lies in the plane of the benzene ring. As a result, this benzene ring in ortho substitute benzoic acid cannot access the plus R group. Cannot access the plus R group. That means, the extent of this pi-pi conjugation, if you will compare in both the cases, the extent of this pi-pi conjugation is higher. The extent of the pi-pi conjugation in the benzoic acid is higher. As a result, this extent of pi-pi conjugation prevents the extent of lone pair pi bond conjugation in the benzoic acid. When you will come to the ortho substituted benzoic acids, the extent of the pi-pi conjugation is lesser. As a result, the extent of lone pair pi bond conjugation is higher. Among these two, the extent of lone pair pi bond conjugation is in ortho substituted benzoic acid is higher. Ortho substituted benzoic acid is higher. As a result, the oxygen of the OH group gets more positive charge. As a result, the oxygen of the OH group gets more positive character. Oxygen is more electronegative. On that one, positive charge density is increased, means its electronegativity is increased. Means it can pull the bond pair of electrons towards itself greatly. As a result, it can able to pull the OH bonded electrons towards itself. By pulling the OH bonded electrons towards itself, it releases the hydrogen atom as H plus readily than the benzoic acid. That means an ortho substituent prevents the coplanarity of the benzene ring and the COH group. In this manner, the extent of lone pair pi bond conjugation is increased. As a result, the acidic strength is increased. Irrespective of the polarity of the ortho substituent, that means whether it is the plus R group or the minus I group or the plus I group, whatever it may be, irrespective of the polarity of the ortho substituent, nearly all ortho substituted benzoic acids acidic strength is higher than benzoic acid. Because in between the COOH2 methyl group, steric inhibition of resonance is operated. Because of the steric effects between the benzene ring to COOH, resonance is not operated. Resonance is not operated. Larger the ortho substituent, For example, in place of the methyl, if I will take the tertiary butyl group, larger the ortho substituent, larger the steric inhibition of resonance. Larger the steric inhibition of resonance means the extent of lone pair pi bond conjugation is higher. That means acidic strength is higher. When you will take the benzoic acid and ortho-methyl benzoic acid and ortho-tertiary butyl benzoic acid, among these three cases, because of the large size of the tertiary butyl group, greater steric inhibition of resonance is operated. Greater the steric inhibition of resonance, greater the acidic strength. That means third one is more acidic than second one. Second one in turn is more acidic than first one. Similarly, if you will take the 2,6-dimethyl benzoic acid, here in the third case, at both ortho places methyl groups are there, so that more steric inhibition of resonance is operated. Greater the steric inhibition of resonance, greater the acidic strength. That means this is the order of acidic strength of these three. Similarly, two 6-dimethyl 4-nitroaniline, this one, and the 3,5-dimethyl 4-nitroaniline. In the second case, the oxidants of the para-NO2 group is sterically forced out of the plane of the benzene ring by the methyl groups. As a result, this NO2 cannot enter into resonance. Means it cannot withdrawing group through resonance. It is not a withdrawing group through resonance. But in the first case, this NO2 can enter into resonance. Can enter into resonance in this manner. As a result, in the first case, the availability of lone pair on the nitrogen of NH2 group is less for protonation, but in the second case, the availability of lone pair on the nitrogen of NH2 group is higher for protonation. So, the basic strength of the second one is higher than first one. In the first case, the NO2 acts as minus R and minus I, but in the second case, that NO2 acts as only minus I but not minus R. Because of the steric inhibition of resonance, the second one is a stronger base than the first one.